All right, today I'm going to record using white paper, and we'll see if that helps the clarity a little bit. We're on day 2 of section 1.3, and just to refer you back to the notes from yesterday, when you were simplifying square roots, you need to make sure the radicand, so the value underneath the square root sign, has no perfect squares. Let's put an S on that. No perfect square factors except for 1. And there are no radicals in the denominator. This is what we're going to work on today. And then you always need to make sure we're dealing with fractions today. Always reduce your fractions if you can. All right, so that's rationalizing the denominator, step number 2. Basically means can't have a square root in the denominator of your fraction. All right, let's look at what happens with square root signs. When you have square root signs, if I do the square root of 3 times the square root of 3, I know that's the square root of 9. Well, the square root of 9 simplified is just the number 3. So that happens with any number that you can think of. If you multiply the square root of a number by itself, the square root sign goes away. So I could do square root of 1,496 times the square root of 1,496, and I'll end up with just the number 1,496. So, for that reason, sometimes in order to get rid of a radical in the denominator, you need to multiply the denominator by itself. All right, let's look at the first example here. We have 2 times the square root of 5. Well, we can't have the square root of 5 in the denominator, or it's not simplified. So if I multiply it by itself, so square root of 5, I've changed the entire value of that fraction. So whatever I do to the denominator, I also need to do to the numerator. So that means I'm going to multiply the numerator by the square root of 5. And this is okay. I'm not going to change the value of this any because this is like multiplying by 1. So I'm just rewriting here. So I multiply these two together. Now, this number has a radical, this one a radical sign. This one does not. Think of people. People who are not radical generally do not like to be around people who are radical. They're just a little too wild for them. So same thing with numbers. They're not going to mix. So in the numerator, we're just going to have 2 times the square root of 5. And we're going to put that over. Square root of 5 times the square root of 5 is just the number 5. Oops, sounds like my husband's outside mowing the yard. Okay, now we have the square root of 5 times the square root of 5, if you want to think of it this way, is just square root of 25, and the square root of 25 is 5. So that's how the denominator gets rationalized. Next question. We have a square root in the denominator again, so we're going to multiply it by itself, so square root of 7. And because we're multiplying the denominator, we also have to multiply the numerator by the square root of 7. Radicals can be multiplied together. So we can say 3 times the square root of 42 over just the number 7. All right, now 42 is a large number. We need to see if we can take out any perfect squares from 42. So I'm going to start over here on the side and just say, okay, well 42 is an even number, so if I do 2 and 21, 2 is prime. I need to keep going with 21, so divide by 3 and 7. Those are both primes. And now I can write 42 as a square root of 2 times 3 times 7. There are no pairs there, so that's as far as we can go. That looks like a big number, but we can't simplify that any further, and you always have to check. Now, I want to ask you the question. 42 and 7, can we reduce those? And the answer is no, because one has a square root and one does not. So we cannot reduce. Letter G, same thing here. We have the square root of 10, so we're going to multiply it by itself. Square root of 10, which means I need to multiply the numerator by the square root of 10. These cannot be combined to say the square root of 50 because one has a radical sign and one does not. So this is going to equal 5 times the square root of 10, and we're going to put that over just the number 10. Now, here I can reduce over multiplication sign. That's okay. I can divide the numerator and the denominator by 5. So this, always check and see if you can reduce your fractions. Divide by 5, divide by 5. So this is going to be the square root of 10 over 2. What I can't do is reduce here. I cannot do that because this has a radical sign and this does not. These are okay over a multiplication sign. Now if that were an addition sign or a subtraction sign, we couldn't do that. All right, square roots that have the same radicands are called like radicals. And here are some examples. Like radicals. Notice in red here we have the square or 2 underneath both radical signs. So they're like radicals. We have 15 underneath. It doesn't matter what's out in front here. That doesn't matter. Just what's underneath. Same variables raised to the same power. So those are like radicals. What are not like radicals? 2 is underneath the radical, 5. So I'm just going to circle. Whoops, I kind of made a bad circle there. But here's 5 and 2. They are under the radicals. They are not alike. Here's x and 3x. They have to be exactly identical. And they're not. So not like radicals. Here the square is on the y. Here it's on the x. So again, not like radicals. Okay, let's look at these and see if we can pick out the like radicals. Up here they were nice. They were all simplified. So here, all right, so picking up, again, asking the question if we are going to circle like radical terms. Well, these two are easy to spot because they both have the square root of 3. So this is a like, or is a like radical with this one. Now 5 is prime, so we don't have to worry about this. This one doesn't have a radical, so we don't have to worry about that one. But 12 we need to look at. 12, if we use the factor tree, it's even, so I'm going to do 2 and 6. Even again, 2 and 3. I'm going to circle all the prime numbers, put them underneath a radical sign. 2, 2, 3. And I'll circle like radicals. So this is going to be, I have a pair, so it comes out as 2. And again, remember the reason for that. You know the square root of 4 equals 2, but if I factor that, I have 2 times 2. I circle a pair because it's square root, and I bring that 2 out. That's why the answer is 2. So here I now have, I'm going to rewrite this as 2, 3 is left underneath, times the square root of 3. Okay, so now this is also a like radical. So make sure you simplify first. Okay, adding and subtracting square roots. We want to simplify each radical term, which is what we did right here. We simplified the square root of 12, and now we can easily see that it's a like radical with like radicals are the first 3. And then we want to combine like radical terms by adding or subtracting their coefficients, not the radicand. So we don't do anything with the number underneath. It's kind of like when you do 2x plus 2, or 2x plus, let's do 5x. These are like terms. Those are the same. Now we can add them together, and we only add the 2 and the 5 to get 7x. So let's do a couple of examples here. We have 5 times the square root of 3 plus 4 times the square root of 3. We can easily see these are like radicals. So once we've decided they're like radicals, the radicals stay the same, and we just either add or subtract the coefficients. So 5 plus 4 is 9. So we have 9 times the square root of 3. These do not look like they're like radicals. 7 is a prime number, so we can't simplify that. However, 63, if we take that off to the side here, 63, I can do 7 times 9. 7 is a prime number. 9 breaks up into 3 times 3, and those are both prime numbers, so I can't go any further. I'm going to rewrite the square root of 63, square root of 63 equals the square root of 3 times 3 times 7. It's a square root. Let me just erase this so it's not too close here now. I'll just put the 3 here and the 3 here. All right, I'm going to circle a pair. That comes out as a 3, and I'm left with 3 times the square root of 7. So I have 4 times the square root of 7 minus 8, because that's what's right here, and then I have to put this 3 times the square root of 7 in. So 8 gets multiplied by 3 times the square root of 7. Now, if you're wondering if you've simplified this correctly, all you need to do is square this. We took the square root of it to take it out. And so now we just square it. 3 squared is 9, and put it back underneath and times it by 7, we get 63. So we know we simplified that okay. All right, now, the radicands are the same. Now we just have to simplify this. So this is 4 square root of 7 minus, this is going to be 24. These have no radical sign, so we can multiply them together, but the square root of 7 has to stay by itself. Last step, now we're going to, these are the same, so all we do is add the coefficients. And this is actually subtracting, so we're going to do 4 minus 24, and that's going to give us a negative 20 multiplied by the square root of 7. And that's your final answer. And now you can go ahead and do your turn questions.